All right, so hello again. We'll continue the journey here, writing algorithm questions. Just give me a few seconds to make sure the audio is working. Here, hello, writing, yep, audio's fine. All right, now, what I want to do is take a moment. I'm actually not sure what am I doing. Oh yeah, so this question is going to be get equal substrings within budget. And we'll continue here. Yeah, it's fine. So I can open that, refresh this, take a look, and make sure I have the chat out. I do. Yep. Okay. So this question: get equal substrings within budget. You are given two strings s and t of the same length and an integer max cost. You want to change s to t. Changing the ith character of s to the ith character of t costs s the absolute difference between the ASCII values of the characters s of I and s and t of I. Return the maximum length of a substring of s that can be changed to be the same as the corresponding substring of t with a cost less than or equal to max cost. If there is no substring from s that can be changed to its corresponding substring from t, return 0. So input ABCD to BCDF, max cost is 3, output 3. ABC of S can be changed to BCD. Excuse me, that costs 3, so the maximum length is 3. Not sure I follow. The length could be 100,000 and t could be the same length, and the cost could be 1,000,000. S and t consist of only lowercase English letters. Okay, relatively lower on the submission side and like reasonable acceptance rates. This is like reasonable kind of stats. A lot of upvotes. Okay. Let's see. Of the same length, excuse me, they're the same length of strings. I want to change s to t. Changing the ith character of s to the ith character of t costs this absolute value. Absolute difference between the ASCII values of the characters. Return the maximum length of a substring of s that can be changed to be the same as the corresponding substring of t with a cost less than or equal to max cost. If there is no substring from s that can be changed to its corresponding substring from t, return 0. So I don't want the string itself, just the maximum length. I would say some kind of DP here, but this is probably a sliding window. DP is probably too expensive for the time bounds. 100,000 elements, it's going to be either linear or linear-arithmic, the solution. Very likely a two-pointer sliding window solution, I think. So yeah, I mean, yeah, sliding window is the way to go. You just slide to the right to see how far you can go with while you're still less than the cost. So A to B, B to C, and C to D, and then once you've exceeded the max cost, you just kind of back up a little bit, pop the left element off, and then again continue to the right as far as you can. Yeah, basically a sliding window is, I think, is all you need here. I think this is kind of straightforward. So let me see here. Let's see, start with I is 0. We could do left and right, actually. Left 0, right is 0. Excuse me, result is 0. We're gonna say, excuse me, then we're gonna say a for loop. The right side is going to be incremented while absolute value of the difference between s of r and s of t of r, adding that to the current amount. It's always going to be a current amount as well. If adding this amount to the current amount is going to be less than or equal to max cost, then keep going. Otherwise, stop. Right? And update actually perform that. A better thing to do here is actually just to use an array and just pre-calculate. Actually, maybe it's not better. Take it back. Maybe save a couple operations. Maybe you could save some operations, but I'm not going to do that for now. Maybe usually actually using more memory often doesn't really save you very much, so it's probably not a good idea. And do that. Result equals result in itself. So what's going to happen is start from L, R, add the values, move to the right, just add a bunch of things. And in the first instance, this could be empty. I want to say I want to remove value for L. I would say if current's greater than 0, basically, or really current's greater than S of L, something like that. Like the first, yeah. So what's supposed to happen is I'm going to increment L, but I'm also going to remove R is less than S dot size, right? We'll do R is less than N. This is also R is less than N too here. What's going to happen is on the next iteration, I should say current and decrement by this difference. I could optimize this a little bit, I think, by writing on L. I could write these values to its own array. The problem that I run into here, though, if I try to do it this way, is in some cases, I never even enter this for loop. In which case L into R, so R plus equals L greater than R, right? So if L exceeds R, then I've got to increment R as well. And part of the problem is L, the first instance this occurs, it may not even enter this for loop, in which case the current value is just 0. And if I subtract this amount, then that's kind of a mistake. So I probably want I could do like I'm trying to think how can I do this in a way that's like clean, I suppose, simple, clean. I suppose I could just put in another for loop here and just say, whoa, 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 whoa. L is less than N, and this amount L is less than or equal to the max cost, then if this is greater than the max cost, right? Then keep going. And then set R equal to L. I don't know. and then just if r is less than L, set r equal to L. Yeah, and then that'll imply that this will always fire at least once, right? And then I can always just do ++L. I can do exactly what I had here before. A little confusing, I realize. So here I find a value for L. That's a good starting point. Maybe I go all the way off the edge, set R to L, get the maximum. Result would be just 0, Current would be decremented or incremented, but it doesn't matter at the end. So yeah, I go left to right, skipping certain L values that are not reasonable to consider, and then that guarantees that this R value at least grabs one thing, and then I can subtract that one thing from the L value here. Okay, that's confusing. Yeah, it's a little bit involved, but I think that works. Oof. Okay, it doesn't work. Max cost 3, output 11. What? Oh, this is it actually should be R minus L. Oops, forgot about that. Yes, so depending on how far this goes from L, whoops, there we go. Yeah, this is gonna be, it's gonna have one extra on R that I need to subtract. So it would normally be R minus L plus 1, but I'm gonna subtract that extra 1 anyway. So something like this, I'm gonna go for it, I think. I don't know, the test cases, it would take me some time to go through the different test cases, I suppose. I could try a few things. Let me try something. Let's just do C, X cost, make it like 50. 20. What's C? It's let's do 10. 10. Let's do more things. 2, 3, 4, 5, 6, 7, 8, 9. 2, 3, 4, 5, 6, 7, 8, 10. Let's make the max cost like 15. Something like that. 100. Let's just see how this goes. I don't know if this is correct. It's a little bit complicated, the logic involved. It's wrong. Okay. 2 should be 3. All right. Yeah. Okay. It's good thing I tested it. No. All right. So expected 3, outputs 2. What is the? I guess it's this one at the end. F and D I think is like 1. F and F is 0. F and E, A, B, C, D. A, B, C, D is 4. E, F is 6. So it's 2. Or no, yeah, 1 here, 2 here, and 0 here. So definitely it could fit 3 at the end. Let's see. So interesting. What happened at the end there? Sliding windows sometimes can be a little bit tricky to program correctly. It's clearly a sliding window solution, but it's not so obvious exactly how to code it. I have an idea, but it's not too So 1, 2, 3, L is 1, and R is 3. 0, 1, 2, 3. So I got S and S. And then I got L is 2, L is 3, L is 5, L is 6, 7, 8, 9. Now 0, 1, 2, 3, 4, 5. So yeah, 0, 1, 2, 3, 4, 5. So from 6, from 6 on, it should be L is 6 and R goes straight to 9. Yeah, I don't know what happened there. Oh, this should be minus equals, not plus equals. Whoops, that's probably the mistake. That's probably the mistake. Still wrong here though. What? Get 6, 7, 8 instead of going all the way to 9. That's wrong. 5, 0, 1, 2, 3, 4, 5. And I get to 6, 0, 1, 6. And then L should have updated to 6. What is going on here? Shouldn't this be current? Current should be basically 0. What happened? Should test more things, I think. Current is 15. So there's like before and after, right? 3 different scenarios. Maybe I should put more information to see what's happening at each of these spots. So, oh, I got -5 at some point. No. Number 1, that's not supposed to happen. Oh boy. This is not correct. Whatever I'm doing here is not right. I gotta think about this a little bit more. Yeah, I kind of thought this wouldn't be right. It's a little bit complicated what's happening. Oh, this is supposed to be L, not R. That's why. That's why. That's definitely the reason. I was gonna say, I was like, what? Okay, there we go. I thought it was right, the logic. Yeah. All right. I'm afraid to submit it as it is. Kind of want to generate more test cases. Let me try some things. All right, just try some. 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 6, 7, 8, 9. Let's do like 2. And then 220, something like that. 200. And like, like 20, 10 and 15. And 15. Okay. All right. I need to, I should probably submit this. I think this is correct as it stands. I'm gonna go for it. It could be wrong. It could be something subtle that I'm missing here. But I think I'm okay. All right, got it. Very nice. Okay, a little bit slow, on the slower side. There are quite a few operations that are happening here. It's kind of involved. 96, okay, that's pretty good. It's reasonable. I think 100% is 0. Let's submit it a few more times to see what score I get. See, interesting question. I would say one more, and then yeah, if you like the video, give it a like, subscribe for more, and I'm gonna try to optimize to make this a little bit faster. What I could do is have an array of diffs size n. Initially fill that with zeros, and then say for each int I is 0, I is less than n, increment I. Diffs is going to be diffs of I. It's going to be the absolute value of the difference between s of I and t of I. And then all of these could be just diffs of L, diffs of L. Same thing here, diffs of L. And this is diffs of R. Saves a few operations, right? I could try that as well. Okay, see if that's any faster. I suspect it's actually slower if I do it this way. Oh no! Oh! Uh-oh. Ooh. Whoops. No kidding. Ooh, I didn't even think about that. Is that, wait, how does that happen? Wait, what? Oh. Oh. Yeah, it can happen. Yeah, okay. Oops. I didn't realize that. Okay, so actually this is possibly a wrong answer, actually. Did I use the, what was the, I forgot which, okay. No, oh, not again, no. No. What? What is going on? Huh. I need to use this test case. What did I do? Oh man, it's definitely wrong. It's very wrong. 2 wrong answers now. Oh no. What did I do? What did I do? How can this be possible? How did, if I have L is less than N, L is less than N, this will skip. L is always less than N. What's going on? What? How is that possible? This happens before this happens. L is always going to be less than N. No? Why, when is L not less than N? What is going on? I'm very confused by this. Doesn't make sense to me. This test case. I don't want to get rid of these other test cases, but also maybe I can copy them. What is happening? I also want to debug this test case. Oh well, it's good that I 0, 1. What is going on? Huh? Just paste these in a comment. Come back to those. Why is this happening? What is happening? I'm very confused by this. Very confused by this. So 0, 0, 1, 4. L ends up at 4 over here? Excuse me, L ends up here. That's less than n. Oh, yes. Okay, that's so confusing. This is happening at the end, which means that, I mean, you could just add an extra value. It's fine. Yeah, I thought that was maybe what was going on. That's fine. That's pretty subtle. That's like pretty easy thing to miss, quite frankly. Yes. Yeah, okay. So the other code was wrong. Other code had something of a buffer flow overflow, something of a buffer overflow thing going on. Buffer access overflowed. Yeah, these are not that easy to code properly. Definitely challenging. Dang. Ouch. Ooh, I'm wondering now if I have other buffer overflows in my LeetCode answers that I didn't catch. Ooh. I don't know what to do about that. Think about that. That's not good. It's one of the reasons you practice, though, for sure. It's a good thing that I practice. Yeah, I don't know. I don't know what to make of that. Ouch. It's not much faster, also. 1, 2, 3, 4, 5. Yeah, this is what I was saying. I think it's going to be slower if I do this because this operation is not that slow, but messing around with all this memory is kind of slow. Oh man. Dang, I don't know what to say. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Oof. So my previous solution that I had here. Oh man. This one. Let me try it again. So this is actually wrong. And the reason it's wrong is it actually has an array access here. That's an buffer overflow array access. There's an overflow. So I need to check if L is less than N. Yeah. And this gets branch predicted relatively nicely. I don't need to worry too much about this. Both of these, this doesn't get branch predicted very well. I'm not sure what to do about this one. This is a little bit odd. This should be L is less than N, and R plus equals L greater than R. That's probably what should be going on there. Yeah, if R is less than L. R is less than L, then I should be adding a value to R. That's fine. That'll just make sure it's always in the right spot. And some branch prediction here. Wrong answer. No. Oh my goodness. Ah, so annoying. Come back to that. Of course. No. All right, let me try again. See if I still correct. It's so tricky. These are so tricky, these questions, I have to say. So he uses a really good on memory, but kind of slow. 1, 2, 3, 4, 5. I think I solved this one. 2401. It's also Similar kind of question. Yeah, it's like very close. Optimal in the memory, but not optimal in the run, very close to optimal in the runtime. 1, 2, 3, 4, 5. I think I'm wondering about one, if it's possible to get 100% with this code. I think maybe not. But the other thing I'm wondering about is what is going on with this if statement where, oh, there we go, got it. Sweet, 100%, 100%. Very nice. Nice, beautiful. 1, 2, 3, 4, 5. So I can take a screenshot later. Okay, my question is, can I move this if statement somewhere? I don't like where this if statement is. I think, so as I'm moving the L value to the right, I think it actually comes after it. I think that's what it is. If R is less than L, then it should happen after. I think that's what it is. I think that was what I did wrong. I increment L, I increment R after L, not before L. Yeah. Let me try this. There we go. Okay, there we go. I had the right idea. I did have the right idea. It was just a little bit hard to think it all the way through. Okay. 1, 2, 3, 4, 5, 6. 6. Yeah, this is reasonable. This is pretty good. I like this. This is fine. So this'll handle the array accesses, the extra excessive array accesses appropriately. We skip out on the extra on the memory, and then we also we do a few of these operations, like a couple times. These operations a couple times, just fine. Yeah, just a couple for loops, result, and a. I like doing it this way. I like having a double, like when I'm using a double pointer kind of a solution, just have two for loops to keep it simple. I think it's reasonable. I think there's probably a way to do it where it's not this complicated, but this is okay. There are other questions that are similar to this sort of thing, and it's almost like the same answer for both, same kind of structure. I should remember that. I guess like the more practice I get, the more I'll kind of be able to recognize what I'm looking at and code it appropriately, with one for loop to find a spot for L, another for loop to loop R across, update the result, and then the current value updated only when I don't go over the bounds on L, because I might go over the bounds on L. Yeah, this gets branch predicted reasonably well. And these are just just a couple of branches for each loop. Not too bad. Yeah, just have some guards here to make sure I'm not doing these array accesses. Excessive array accesses. Yeah, interesting question. I don't know, man. I think I struggle with 2-pointer questions, like sliding window questions. I think I always kind of struggle. 1, 2, 3, 4, 5. Yeah, it's always a bit challenging. I think actually it's faster to have this if statement, by the way, to not do it this way. I think I save operations, just one if statement. I think this is actually a faster solution, because yeah, branches are not cheap, but it's also, I'm saving every one of those operations. Like I don't need to be doing that operation every time. I think it's actually more efficient to do it with a branch. This gets branch predicted. This, I don't think there's a way around it. I'm supposed to kind of do it at each step, the iteration, the calculation. And this part's kind of a setup for L. Yeah, that's fine. I think this is good. I like this. I like this approach. I think this is a better approach than the other ideas I've had in the past, where like I try to, you do have to be very careful with this kind of way of doing things, where you have to make sure you don't access things outside of the array bounds. But I think other than that, it's pretty solid. You set up L and then set up R and do that in sequence. And that's much easier to think about for sliding window type questions. I think that's the way to go. I like that. It's maybe not the cleanest code, but it's definitely like easier to think about and a lot faster program. And it's efficient, like it's fine, it's reasonable. Excuse me. Yeah. It's not, maybe not, there's maybe ways to do this more more efficiently, that's more optimized, but it's reasonable as it is. Also, I'm pretty sure I solved this question, and I'm pretty sure this question is a very similar kind of solution, sliding window solution. Okay, all right, that'll be it for me for sliding window for this question. It's a good one. That's a good question. That was challenging. There's definitely stuff in there that's, yeah, mistakes, easy mistakes to make. Really bad one is going outside of the array access. I didn't even notice that. That was pretty bad. The array access bounds, and then that's a big one. That's a big mistake. That's the reason why it's a really big mistake is that you won't necessarily you won't necessarily detect that in your program because it's so subtle. Like it's an extremely subtle bug, and actually a devastating one, by the way. Like you can end up with a real problem if you don't catch something like that. Hey, 100%, very nice. Got it. That's a devastating bug if you don't catch it. And then, so that's really important. And then the other question or sort of issue is like logically this is a lot easier to set up the left side and then set up the right side, and then set up the left side, set up the right side, and then perform the appropriate calculations. Also guarding to make sure the left and right sides don't go out of bounds. They don't start doing array access out of bound array accesses. Yeah, challenging question. I've got to say, challenging question. Interesting. This is correct on their test cases. I'm thinking now if this is actually correct in general. By the way, this particular approach is a little bit awkward. Interesting. I think it's fine, actually. I think it's fine. Yeah, because I don't need to, I don't actually need to check it after I subtract this part, right? This part, even if I go right straight in here and current is still larger than the max cost, I don't need to keep moving the left side down to the right in order to check. I don't need to keep moving the left side down to the right in order to get a like a better maximum array size, if that makes sense. Because it's got this outer loop will handle that, and like the issue is that well, yeah, actually this outer loop will handle that. It'll just do that automatically. It'll just keep repeating this a few times. Yeah, that's fine. Yeah, that's why I don't need to check. I don't need to check. What I'm trying to say is I don't need to check more than this condition here. This is really just the initial, really to find an initial position, actually. This probably could just be one. This probably could be just one iteration, quite frankly, when I think about it. No, it's got to happen every time because yeah, you could reach a spot where the value itself is just too large, and you basically would just get into a weird position. Yeah. Yeah, if the value itself is too large, then you gotta just shift forward with using this. Yeah, I think setting up L is just the right way to go. All right. Yeah, it's a challenging question. There's a lot to kind of think about here. A lot of details. Programming is definitely pretty challenging, I gotta say. I gotta say, it's like, it's kind of hard. It's kind of hard. I gotta admit that. It really is. There's like there's a lot of details. A lot of details. All right. Anyway, okay. Let me get going. Yeah, if you liked the video, give it a like and subscribe for more. I think I'm gonna take a break for a few minutes after this. This was kind of a tough one. Had to really think about it. Made some mistakes too, which is not great. It's important to just keep practicing and kind of like not make those mistakes. That's like I said, that was like a really critical mistake because it's very subtle and creates technically a security opening where you could start. Well, you get a potential security exploit if you have code in production that does that. Yeah, that's. I often wonder. It's like, well, how do people create buffer overflow errors? It's like that's how. That's how. They have relatively complicated things that they're doing, and they don't realize that in their testing they don't catch that they they had an off by 1 or something on their arrays and created a buffer overflow error. Dang. But anyway, all right.